The slumbering giant that is America has finally awakened.
Chips is now at the very heart of US-China tensions.
Technological leadership has been the source of U.S. strength since World War II.
We shouldn't be dependent on any one port, any one country, any one island.
An economic competition that is manageable could turn into something bigger and hotter and unmanageable.
American manufacturing, the backbone of our economy, began to get hollowed out. Companies moved jobs overseas. Today, we're down to producing only around 10% of the world's chips, despite leading the world in research and design of new chip technologies. But folks, where is it written? Where is it written that America can't lead the world once again in manufacturing?
It's hard to think of a component in any product, really, that's more ubiquitous and more essential than the semiconductor.
Today, almost any device with an on-off switch has one or often dozens or hundreds of semiconductors inside.
They power our cars, airplanes, trains, communications rely on them, factories, ordinary businesses and finance and banks. Money moves thanks to these chips.
U.S. no longer manufactures the most innovative chips. 7 nanometers and below, Taiwan manufactures 92% of those chips. 8% of those chips are manufactured in South Korea, and none are manufactured in the U.S. We just want more of the new manufacturing that's coming online to happen in the U.S.
There was a sense that globalization is inevitable. We should offshore these jobs. No big deal if the Rust Belt is hollowed out. That decision is one of the reasons that the US elected Donald Trump. And that is why Joe Biden is pushing industrial strategy. And that is why we are at a pendulum shift in the political economy, not just in the US, but in many developed countries.
When people think about industrial policy, it has been a bit of a dirty word in the U.S. politic. And hey, free market should reign. This is not like any other industry. This is so critical for the future. And I think that's why, it really deserves somewhat unique attention from an industrial policy perspective.
Members of Congress, I have the high privilege and distinct honor to present to you the President of the United States.
We're going to make sure the supply chain for America begins in America. That's why we came together to pass the Bipartisan Chips and Science Act.
This is really the crowning jewel in the Biden policy crown.
So what's behind the CHIPS Act is an attempt to protect the economic security of the US far into the future.
The whole CHIPS Act is $52.7 billion. $39 billion is for grants. There's also an investment tax credit on top of this, which gives a 25% tax credit off of any fab that's constructed or improved upon.
The focus of the CHIPS Act is on producing the chips that the U.S. needs for its national security requirements. Department of Defense, the intelligence agencies, and the associated companies that are going to build products for them.
As the US looks to become a real leader in global chip making again, it's looking at creating centers across the country where it can build up on the skills both of the people and of the local suppliers that are needed around these large chip fabs. These are fabrication plants. These are the big factories, and they produce the wafers, like large discs of silicon, on which chips are printed and then cut. So this is really at the heart of all chip making. And these plants cost tens of billions of dollars.
You have some of the largest industrial projects that have ever been undertaken, and they're building the smallest things that have ever been built on Earth. And if we get there, we have good transistors and a good cost structure, we're going to win foundry customers, and manufacturing will shift back to the US. Today, the Rust Belt ends. Today, the Silicon Heartland begins.
Phoenix has been named as one of 5 U.S. workforce hubs focused on manufacturing jobs.
It is really an exciting day to be here, and this builds on 40 years that Intel has been in Arizona. We put our chips on the table, right, with this investment. Now we're going to put our shovels in the ground and get this thing underway. And we are excited for the opportunity to expand and now have over $50 billion of invested capital in the state of Arizona.
Arizona's been a center of semiconductor manufacturing in the US for several decades, but in the past couple of years, it's seen major new investments, both from Intel and from TSMC, both of which are building brand new cutting-edge chip-making facilities.
Advanced manufacturing has been an incredible industry for Arizona, and part of the reason I'm so focused in on it as mayor is I feel that it'll develop a healthier economy, more diverse, and that so much of the future of the world's technologies will need chips, which are going to be made here in Phoenix. The CHIPS Act is going to change Phoenix forever. We have seen unemployment rates change, and we're also working on the workforce side, and we were recently selected by the White House as one of 5 workforce hubs. I'm very focused on trying to create a knowledge-based economy with high-wage jobs. That's why I'm betting on the semiconductor industry. Arizona State University has been a key partner in our semiconductor expansion.
The rate at which the technology is moving, that is the smallness of the features, right? You hear about 3 nanometer, you hear about 2 nanometer. This is coming, okay? And those are really pushing the boundaries of what physics will allow. Well, how do we solve that problem? That gets an engineering student excited. Engineering and these students, they want to solve problems.
My name is Mark Lee. I'm from Kazakhstan. I was really interested into working in semiconductor industry. I chose material science because material science is something that people in the industry are looking for. I'm interested to be an inventor and making technology in a specific area. Inventing new materials to improve the chips, trying to make an impact on our society. Now I feel like I'm getting very close to that dream. This is our clean room, and we have a lot of tools. But you could notice one of the things you would start noticing right away. This area is white, that area is yellow. And again, coming back to when you do any sort of lithography work, when you're exposing a film and you're developing it, you want to have no UV light.
The US doesn't have all the talent to staff these fabs. You're going to need about 27,000 people with fairly high technical skills over the next 5 to 10 years, because we're going to need thousands of people from outside the US with the right skills, which means we're going to have to facilitate the immigration of these people.
US has such an environment where you can succeed if you want to. If you really strive for something, you can achieve it. And that's what attracts me in US. I didn't feel the same way back in my country.
Talent is a big challenge we need to overcome. There's 2 sides of it. One, we need to work harder on STEM education. That's one side of the coin, and that's going to fix the medium and long term. The short term, we need to have some modifications to our immigration policy, which is very, very broken for high-skilled immigration.
If you look at the founding of Silicon Valley, there were workers from Europe, from Korea, from Egypt, for example, in the founding of some of the earliest companies in Silicon Valley.
It's an area of concern, it's an area of priority in the CHIPS Act and funding some of that skills development. But at the same time, I look at this and the response that we've gotten, for instance, from university system in the US, at the community college level, at the university level, the top tier schools, has been phenomenal.
Intel is one of the most underrated stories in the tech industry, and that's a big thing to say given how prominent it's been and everybody knows the brand. But what I don't think people appreciate is that for about half a century, this company was the complete leader in an entire industry. It invented integrated circuits, which are what we think of as microprocessors, as chips. And it basically led that industry in manufacturing for a half a century. And what that meant was that with each new generation of chips it designed, it also developed the manufacturing processes to build them. And it was developing things that were smaller and faster than anybody else could design. And it was typically 2 to 3 years or even more ahead of the entire global chip industry. But what's happened more recently is a different story. In the last 5 to 8 years, Intel lost its edge. It lost its ability to just keep staying one step ahead of the rivals, if you like. And other companies caught up.
The plan that I've laid out for Intel says that we'll invest about $30 billion in capital per year for 5 years. $150 billion. These are extraordinary investments. And when you go look at those of TSMC or Samsung, they're similar. We've been declining for 30 years. Can we start inclining for the next 30 years?
Here is a world where material is grown into crystals with controlled impurities, with intolerances which are molecular, even atomic. The objective? Semiconductors, transistors and diodes needed by the millions.
So at the very beginning of the chip age, Gordon Moore, who was one of the founders of Intel, was looking for a way to explain to people how chips were going to be in everything, how electronics, the whole world of electronics, was about to go through a revolution that nobody could quite understand.
In 1965, Gordon Moore set out in a paper what became known as Moore's Law. And the idea behind it was that the number of transistors per chip would double every year or two. And that was just a prediction. It's not a law of nature, but it's proven correct for over half a century.
The basic goal, whatever the product, make it smaller, more reliable, more economical, extend its function.
If you go to the store and buy a new smartphone, just the primary semiconductor on the phone will have 10 or 20 billion tiny transistors carved into the silicon. And each one of those transistors is so small, it's roughly the size of a coronavirus. And there's no device that we've produced at such vast scale using such microscopic components. Now, as transistors get smaller and smaller, it's getting harder than ever before to shrink them further. Major companies like Intel or TSMC, they've outlined very clear pathways to keep Moore's Law alive for years to come.
Till the periodic table is exhausted, Moore's Law isn't finished, right? We're just going to, keep bending the edge of science to find, how to keep these advancements underway.
For the future of AI, for the future of all sorts of technological advances, it's absolutely critical that we keep this rate of innovation happening as rapidly as possible for many years into the future.
Chips have been at the center of electronics and computing from the very beginning. And it's been very easy to ignore them. They're just there, we take them for granted. But all that's changed. We've all discovered during the pandemic that an interruption of chip supplies can affect everything, can affect all manufacturing industries. So suddenly the chip world is being turned on its head, and Intel in the all-purpose chip world is really trying to rethink its role.
6 million vehicles were taken out of production plans in 2021 due to the semiconductor shortage.
Over the course of 2021 and 2022, car companies globally saw several $100 billion in lost sales because they couldn't get the chips they needed to finish their cars.
Car lines shut down just because there weren't enough chips available. Car makers cut their purchases of chips thinking they would sell fewer cars. And so all the chip makers instead sold to PC companies. And then suddenly there was a whiplash. How do we de-risk? How do we make sure that we have multiple suppliers so that we aren't reliant on a single supplier? And how do we make sure there's enough capacity in the supply chain?
Today, 90% of the world's most advanced processors, the types of chips in your smartphone or PC or in data centers and telecoms infrastructures, can only be produced by TSMC, which has all of its most advanced production in Taiwan.
In 1990, we manufactured 37% of semiconductors here on US shores. Now we manufacture 12% and falling. Overconcentration of manufacturing in East Asia is neither good for our national security or economic security.
TSMC, the global leader at the moment, basically focuses most of its manufacturing close to its home and operates absolutely massive plants with huge output.
When the company was founded in 1987, it had a really unique business model. It would only manufacture chips, not design any in-house. And that business model let it serve a wide variety of customers, companies like Apple or NVIDIA. And as a result, it's grown far larger than any other chip maker of its kind. And because of its scale, it's been able to drive down costs, but also hone its technology, because for every silicon wafer it produces, it gathers data, hones its production processes. And so it's not a coincidence that TSMC is both the world's largest chip maker, it's also the world's advanced chip maker.
Should we have 92% of all semiconductors in Taiwan? Maybe not such a good idea. That's an incredible vulnerability, and it really makes you stop and think, how did we get to a place where countries and companies thought that this was okay? You know, I think a lot about what would happen in this country and around the world if there were to be a blockade of Taiwan, if there were to be a hot war in the South China Seas. The only near-term comparison we have to something like this is the war in Ukraine. That created a global market event. We had inflation, we had huge corrections, we had, both in companies and countries. An interruption of the supply chains, not just in chips, but in everything through the South China Seas would be 1,000 times that.
This is a bad day for President Xi and the Chinese Communist Party. The slumbering giant that is America has finally awakened to the challenge that we face from the People's Republic of China, their aggressive posture in the region, and the potential they would have of cutting off our access to advanced semiconductors.
Another day of unpredictable Chinese drills around Taiwan this morning, simulating sealing off this self-governed island. Taiwan says dozens of Chinese warplanes once again crossed the very sensitive de facto maritime border of the Taiwan Strait.
Over the past decade, Chinese military power in the Taiwan Straits has grown dramatically as China's ramped up its military spending and focused almost all of its military efforts on threatening Taiwan.
解决台湾问题是中国人自己的事，要由中国人来决定。我们坚持以最大诚意，尽最大努力，争取和平统一的前景，但绝不承诺放弃使用武力。
Imagine what would happen today if instead of an oil embargo like we had in the 1970s, there was a chip embargo.
If the economy collapses, and if there are large interruptions in everyday life and the functioning of society, you could essentially expect production lines across the world to just stop.
The global paradigm is changing, and that creates bumps, and that can create conflict. And there is a real risk at this moment that an economic competition that is manageable could turn into something bigger and hotter and unmanageable, and that really does worry me.
What if China in some way got control of Taiwan? It doesn't have to be an invasion, but a much lower budget approach would be to make sure that the right folks won the next Taiwanese election. And what happens if the Taiwanese government says to the US, thanks a lot, you can go now? Conflict need not be military conflict, and that's a point that gets lost. We have a chance to manage that conflict using things like export controls, using things like industrial policy, but conflict is inevitable. And that's where the semiconductor industry and the CHIPS Act come in.
In the tension that's emerged between the US and China, the computing industry and the tech industry is at the heart of future global competitiveness and national security. And in that tech rivalry that's emerged, chips are right at the center. The US has realized that it's China's lack of a real skill in making advanced chips that is the only thing that's holding it back from becoming an advanced technology power. And so the US is actively acting to stop China gaining that chip technology.
It's not in our interest to provide technology to China that could be used against us. And at a time when it's engaged in a buildup of its nuclear weapons program in a very opaque way.
Today, China is a relatively minor player in the chip industry. China spends as much money each year importing semiconductors as it spends importing oil. And China has to buy all these semiconductors from abroad because its domestic capabilities at the cutting edge are quite limited.
In addition to the 25 to 30% it consumes, it has another 25 to 30% of world supply chain goes through China. So it plays a critical role in the supply chain as well.
In 2014, Chinese President Xi Jinping identified semiconductors as a core technology that China should produce domestically. And since that point, China has poured tens of billions of dollars a year, roughly one CHIPS Act a year, into subsidizing its own domestic production.
为推进强国建设、民族复兴，做出我们这一代人的应有贡献。
The semiconductor industry has become like a symbol of whether China can build its own self-reliance technology industry. At the center of the government-led investment is the National Integrated Circuits Fund, known as the Big Fund. So big funds have been raising 340 billion renminbi, which is $47 billion, since 2014. And so far, with little fruit from such a big investment, so Beijing have to basically rethink whether this such an approach it's useful.
In aggregate, Chinese chip industry still lags behind technologically, despite all these generous subsidies. And when you look across the supply chain, China is years behind the cutting edge in Taiwan, Korea, or other countries. The big shift that we're seeing is more of a bifurcation between the China-focused chip industry and the chip industry selling to the rest of the world.
It's not just the basic science that has to be grokked, but there's a lot of tacit knowledge, if you wish, shop floor knowledge into how to make it work that's very hard to replicate. TSMC has a tremendous amount of shop floor knowledge, that tacit knowledge of their workers of how to make those processes actually run and produce high yields.
The US is considering tightening curbs on the export of chips to China.
Advanced semiconductors, a key development and national security priority in China.
我叫吴子豪，然后我是出生在台湾，因为90年代的这个半导体是所有台湾这个理工科系大学毕业生的一个首选的一个工作，所以说我在99年呢也加入了这个第一个工作就是台积电啊，那我是在台积电的 Fab 3厂去担任这个厂务工程师，那后面的就是这个是我加入这个芯片行业的一个初衷啊，也是一个开始。那目前我是从事了这些半导体的咨询工作。那这咨询呢，第一个其实主要分为2个部分。第一个呢，面向的是半导体企业的这个咨询服务，比如说帮他们做一些经营啊，以及未来的这个战略方向的一些规划。第二个主要是面对这些金融机构，金融机构现在我们有一些1级的这些投行，他们需要新的这些标的，投资一些新的标的初创企业。在去年美国10月7号出台了这个对中国限制的这个法案之后呢，其实我们觉得这个是一个历史的一个转折点。这个禁令是全国性的它不是个别企业，那等于这个也正式的这个打响了这个中美的一个科技竞争，因为那28纳米以下的这个我们归类为先进的这个制程呢，目前肯定是对中国来说是极度缺乏了，而且也是中国是很想去重点投入这一块的。那当然这个也是因为中国的极度想进入了这个领域，也是美国重点要针对中国打击的一个先进制程，就是中美的一个争夺的一个要点。中国它缺乏的是一个比较专业又客观公正的一个可以这产业的一些专家了。因为这几年的发展其实目前整个市场上就是能去说真话的不多，因为都基本上是以宣传为主，尤其是企业，就是国内的中国的这个半导体企业，他们在市场 只希望宣传好的一面。那所以说，真实的一面呢，往往可能会被忽略。那我认为这个对整个行业的发展是不利的。必须还是要透明、公开，然后让决策者、让政府呢有一个很好的去判断。
That we seek competition, not conflict. Investing in our alliances and working with our allies to protect advanced technologies so they will not be used against us.
The chip world is now moving into specialized chips for specialized purposes. In AI, that means GPUs, a different type of chip that was originally designed for gaming, but has now been repurposed for AI. And we've seen NVIDIA, which really leads the world in GPUs, become the world's most valuable chip company and indeed hit $1 trillion valuation just on the strength of these single-purpose chips that work well in AI.
It used to be that emerging technologies, especially in the United States, came out of the Department of Defense. Think of it, satellite systems in general, semiconductors themselves, but also things like radar, sonar, GPS that now we can't live without. But because they came out of the national security enterprise of the government, you had a chance for them to diffuse slowly into civilian life, and the US government could manage whatever risks they had of their adversaries using the same technology. Today, there are a bunch of technologies, artificial intelligence being just one of them, where the lead of this is actually happening in the private sector. And the US government is trying to catch up, and as the government appreciates what the national security implications of these technologies are, how does it now try to put rabbits back in the box or manage the risks that these technologies have to the national security?
Competing with China requires everyone on the field operating as a whole of government and working in a bipartisan way with Congress. It requires the use of the full extent of our economic, diplomatic, and military tools.
In 2022, the U.S. imposed new restrictions on the transfer of certain chips used to train artificial intelligence systems to China. Today, almost all of the world's advanced AI chips are designed by U.S. firms and manufactured in Taiwan. And data centers in China that were training AI systems were using these chips as well. And the U.S. wants to limit China's access to these high-end chips with the aim of constraining China's ability to deploy AI systems for defense and intelligence use cases.
Technological leadership has been the source of U.S. strength since World War II. And that was when the U.S. discovered that if you have the most advanced technology, you could make your own security. You could achieve leadership in the world. And a lot of what's happened since then has been an effort to keep America's technological supremacy.
The US and China have been doing a supply chain dance for a couple of decades, maybe 4 decades now. Sometimes it's gone well, other times it's been more dysfunctional. And I think we're really kind of nearing a zero day where we begin to understand, okay, we can't have the status quo anymore, and what are supply chains globally going to look like?